Okay, what I would like to show you in this example is how to create several trails based upon the network that we've just covered. Instead of having one big trail, we will have several trails that will be driven by either other particles or an animated set of points that could belong to other geometry. So let's get started. First of all, let's have a look at our previous network. So inside, this was the network that we used basically for generating this single trail. So what I'm going to do is I'm going to copy this network, just the entire network that we're currently using, so copy, paste, right? And the previous one, so the old network, I'm going to put this in a network box. So I'm going to press Ctrl N to put a network box around this, and I'm going to call this original trail. Yeah. And let's just give it a quick color so you can easily identify this. So what I'm going to do now is I'm going to change it a little bit so that we have several trails. This is exactly the same network. Now what is the problem that is starting to happen? It's basically that if we try to put this entire operation into sort of a big copy stamp operation, that won't work with these particle operator networks, with these pop networks, because pop networks are dependent upon the previous frame and copy stamping just does not work. So what we will be doing instead is we will do the copy stamping after the pop network. So instead of having two pop networks, we will have one pop network that calculates everything, and then we will have the copy stamping based upon that. Alright, so let's start. Maybe instead of a box I'm just going to change this and have a sphere in there. Yeah. So it's exactly the same network. I've just made a little copy of it, and I'm going to set my sphere to polygon. Yeah? And I'm going to reduce the frequency of it a little bit. Let's make it visible, and let's just frame up on it by pressing F. And I'm going to put this at the moment to flat wire shaded, or rather hidden line ghost. There. So this will be the amount of detail that I'll be sort of working with in the beginning. So if I just have a little look what's going on. So the transform that is occurring at the moment is the same transform as with the box, and will be driving sort of the particles. There will be trails generated from all these points. So the way that it worked in the previous case was with two groups, group A and group B. We won't be using these two groups anymore, so I'm just going to delete them. The next step is I said I'm only going to be using one pop net, so I'm going to delete one of my pop networks, right? And the way that this basically will start to work is once one branch will sort of branch off and in the same way generate all this, and the skinning will remain. But first of all I'm going to copy some lines, and those lines will then be used to emit the trail from. So I start off with just a normal line. Lay down a copy, right, and let's just plug this into the template and plug this into the object. So now as you can see, there are all these lines are copied onto the points, right? They're all the same length and they're not moving except for the movement of the template geometry, right? But so basically all these two lines, they will be the ones that leave the points behind. Okay, so let's just make sure that one more thing is that if we just home in on the line, I want the line to be around the origin, so that once I start copy stamping with this line and I start spinning it around and rotating around, I basically am able to have it around the center point. So what I'll do is I use this distance attribute, copy the parameter and put it in the origin, so copy paste relative reference. I'm going to make it negative and divide this by 2, so this will exactly put it in the middle, this little expression. And now what I can start to do is use a transform underneath this, right, as such, and I'm going to put a little expression inside of the rotate channel. So if I just would put something like $t, which stands for the time, right, then this thing will start to rotate over time as such. Yeah, so very slowly, you know. So what I can do instead is I'm going to multiply this by 360. and now it's gonna rotate a lot quicker. Yeah. And this is obviously too quick. The reason why I'm going to be using 360 in it is that this will represent sort of, you know, the full 360 degrees, you know, of a circle. What I'm going to do now is I'm going to give each of these lines a random offset based upon their stamping, so based upon their copy number. Okay, so the way to go about doing that is just go to the copy, go to stamp inputs, turn this on, and let's type in copy num, just as normal stamping operations, $CY, or rather $PT, since we're using the template point. The template point in this case would be these points, right? And if I take this now and I'm going to start multiplying this, I can say something like a random number, maybe there, a random number. What I want to do is I want to stamp I want to stamp the copy 1, so let's go get the copy 1, there we go. Now the attribute I want to stamp is copy num, and in case it's not correct I want to say this is going to be -1. Right, so this should give them a bit more variation, right? Now one of the things that can happen, since random will return a number between 0 and 1, is that this number will become sort of very small, and then these guys don't really have any influence anymore. So what I'm going to do is just spread this out a little bit so it's a bit easier to see. And this entire randomization operation, which will return a multiplier between 0 and 1, I'm basically going to say, okay, I'm going to multiply this by 0.8, which in my terms means use 80% of the randomization. Yeah. Then, on top of that 80%, so now the random number is going between 0 and 0.8, I'm going to add 0.2, which basically means that 20% will always be there and the remaining 80% is random, right? This will make sure that this randomization will never zero out the remaining operation. Okay, so one more thing that we can do is also we can use this stamping to say that some of them will start rotating clockwise, some of them will start rotating counterclockwise. The way that we can do that is with a simple if statement, and we will be using the stamping as well in there. So if, and what we sort of want to say is copy num. If this copy num, the modulus of this copy num is equal to 0. So this basically means nothing more than if the copy number is even or odd, yeah, then we will do something to it. So then we will say -1 or 1, and we will multiply this with whatever randomized values that we have. So -1 will just basically do the opposite in the rotation, and the 1 will not affect the rotation. Now this copy num, in the same way, we will have to access it with a stamping operation, so just copy paste that from there. Come on. Let's just type it then. Stamp. And it's exactly the same thing, so just copy 1. And I'm going to get the same attribute, copy num. And if it is not there, if the default value, if the attribute is not found, return -1. Alright, so I'm going to say apply. By the way, just to bring up the edit expression is Alt-E. So just apply, accept. So Alt-E to bring that up. Yeah? Okay, let's have a look. Let's have a look just at this point. And so at this point it's just spinning around with a random number. Now if you find that these objects are spinning around too fast, then we can just bring this expression back up and just add, say, a multiplier on top of that. So I really want to have them sort of slow spinning, so I just added my own little multiplier. Again, if you're making this into a digital asset, then you can just you know, linking all these parameters, linking, you know, the time or whatever, linking these parameters into your asset. Okay, so but now if I just bypass this transform for just a second, right, as such, then you can see I've got a bunch of lines moving about, you know, and they're just slowly rotating, each at their own speed. They're all the same size, so though, but we will change that later on as well. But let's continue on for now. So what I'm going to do is I'm going to feed this into my pop network, right? And I'm going to go ahead and let's have a look inside. Okay, the source is sort of red because it's trying to find group A, and group A is deleted, so it's not there. So let's get rid of that, right? In the birthing tab, the problem at the moment is that if this guy is starting to move, and I'm just going to hook this transform up again, so I've got the moving points. When this guy is moving, right, the amount of points that are being emitted do not correspond anymore with the necessary amount. So as you can see, we need a lot more points being emitted, yeah, because the amount of points currently being emitted per frame is not enough. So how do we find out how many points we need to emit? Well, first of all, the frames per second, we know that this frame rate, yeah, this 24 frames or 24 points, you know, will basically give us what one trail would give us. So what I need to do now is I need to find out how many of these primitives, how many of these trails I have. Okay, so the way that we can do that is just before we go into the popnet, I'm going to lay down a null, right? And this null will be useful to us because we will be able to reference it. So what I'm going to call this is sort of null base geo to pops, and this will basically tell me, yeah, is the geometry that will go into pops, and I can now reference that. And I'm going to use a little expression which is number of points. So I want to know how many points there are. One level up, so now I'm at the pops level, now I'm back at subs, right? And I'm going to paste the name of that operator, that sub in there. Okay, so that's the number of points, and this will basically return me now 24 times whatever number I've got there. So this would be 24 times 24, right? Okay, and let's have a look what this does, right? Okay, so we've got a bunch of points going now, and as you can see, you can already start to see the trails. You know, you can see the trail that this guy is leaving behind, and there's one trail and another. Now, one thing which is kind of useful to us, yeah, and is something we will be using as well, is if I just go up a little bit, and I'm going to make this one reference, so we can have a better look at it. So let's pick a trail that's fairly visible to see. So let's have a look in specific at this trail, right? So you can kind of start analyzing what's going on. First of all, notice that this point, yeah, 723, 722, at this side it is odd, at this side it is even. Again, the trail that it leaves behind will follow the same kind of principle because the way it's being emitted. So this side is even, this side is odd, odd, even, right? So all the numbers that are on one side of the trail will be even, all the numbers on the other side of the trail will be odd. We will be using this to sort of build up our lines and then build up our skinning operation. So we'll group all of these numbers into an even group and all of the other numbers into, well, we won't group those, we will use the opposite group. So let's go inside and do that. So I'm going to add a little group on the end of this, right? And instead of my rule, right, I'm going to enable my rule, and instead of saying that, I'm going to say if $ID, so the particle ID, the unique ID, modulus 2, right, is equal to 0, right, put it in one group. And I'm going to name this group even group, and over there just use $OS to get the name of the group. Alright, let's go back up, And if we just rewind this, play it again, then we should be able to see the amount of points that are currently inside of that group. So as you can see over there, 480 points in even group. So the nice thing about that is, if we now add a new delete operator and connect it to, say, one side, then we can say over there delete, right? And we can use this group, delete even group, make sure your entity is set to points, points. And as I just switched this off, you can already see what's going on, right? So I just deleted one part of the trails, so one part of the trails is just completely gone. So let's do the same thing on the other side, right? Delete there, and instead of that delete selected, I'm going to say delete non-selected, right? And plug it in there. So if I just quickly switch between the two, then you can see the different sort of paths. So notice at this side it's at the right side, at this side it jumps, it's at the left side. So one side is sort of dealing with the left side, the other side is dealing with the right side. So that's good. There's a slight difference going on, which basically has to do with the deletion of the unused groups. Over there basically there are no groups, whereas in this example the even group is still there. So if we want to be clean about it, we could just add a little group operator in there to get rid of that group as well. So we can go, instead of creating a new group, we're just going to ignore this tab and we're going to disable this by number, so we don't create new groups. I'm going to edit, delete, and over there I'm going to check my even group. So this will basically just be a group operator that gets rid of this even group, right? So if you look sort of further down the line, sort of over there, right, then you can see at the moment there are no groups in that one as well. Okay. So now I want to start sort of differentiating every single trail, right, and start looping through a big copy operation. So I'll do that in the next section.